All right, yesterday we looked at functions. Quite a few of you came to class, some of you still doing what we used to last year, but anywho, stuff goes on. It said determine if each relationship represents a function. And we learned several different things yesterday about functions. Somebody found your notes yesterday who attended class. Function has exactly one input for every output. And I kept saying one thing all yesterday. What was that one thing? X cannot what? X cannot what? Good job. Thank you, somebody. Who was that? Khalil? Very young. Good job. Thank you, ma'am. X cannot repeat. That means if I did not attend class, my hand should be moving. X cannot repeat. And then there were 5 different things we discussed. Mapping diagram. What do we say about mapping diagram? All right, that first one is an example of a mapping diagram. Notice they got arrows to go from the input to the output. So what we'll do, we want to check these arrows to make sure these X coordinates aren't going to more than one. Are they going to more than one? No X repeats. Yes, it's a function. Y'all know me, you used to me, I don't have one model. Everything needs what? Work or explanation. I'm not a hard person. Either you showing me what you know or you telling me what you know. But don't assume I'm supposed to know what you know. All right, what was another one we discussed yesterday? Tables. Oh, that's graph. All right, with graphs, we use what's called the pencil line test. That's why she said use your pencil. Another name for it is called the vertical line test. And you do exactly now and start to tell us, we're going to put our pencil to it. I mean, I'm going to hold my pencil up and down, and I'm going to slide across that graph and see if I'm touching more than one point at once. Am I? Am I ever touching more than one point at one time? At 1, at 2, 3, and at 4. So I would simply say X repeat. So no, that's not a function. Well, they give us a graph, pencil line test, put it up, slide it across. What was another one we discussed yesterday? Tables. What did we say about tables? X can't repeat again. And notice I'm only talking about the X. I don't care nothing about the Y. And I need you to give me that same mindset with functions. We're not worried about the Y, we only worried about the X. So in this table, I'm only looking at the X. Do any of them repeat? So that means it is not a function. And I would say 7 repeated. What was another one we discussed yesterday? Equation. What did we say about equation? It's either going to be in the form of y equals mx. Good job. Or y equals mx plus b. Equation is going to be in those 2 forms. You got all this from yesterday. And then you see your class, but okay. You get your little zeros, you better ask them cheering. You love summer school too, you better ask them. So anywho, so looking at D, would you say D is in either one of those forms? Yes, it's in the form of y equals mx. And you could have said that y equals mx. Form of y equals mx. So yes, it's an equation. E. A lot of us said it's not a function. Now go back to your notes from yesterday, so with equation, I gave us a little piece at the bottom that said if it's not solved for y, what do I need to do?
1 x squared minus 2
right there. If it's not solved for y, who got the notes from yesterday? The last piece, if not solved for y, when we discuss the equation. That's your example, or y. The last, if not solved for y, I think I said something like that. No, second. If equation is not solved for y, all right, so notice these equations. They start with y equals. So that means if it's not solved for y, we need to try to get y by itself. So let's take e. X is equal to y minus 1. What can we do to get y by itself? What's over there with? -1. So if it's negative, what do I need to do? So if we add 1 on both sides, we now have y is equal to what? Just x? X? Okay, yeah, so y'all of x plus 1. Is it now in one of those forms? Yeah. So if it's not solved, solve it for y. Before you just say, no, it's not fun, okay? Any questions about number 1? You received a question mark, that means I'm missing something. Told y'all I'm done. I don't know nothing. I only know what you give me. Number 2. It said Audrey needs to remove 1 point from the graph shown so it represents a function. Which point can she remove? What do we know about graph? Okay, we can use the test, vertical line test or pencil line test. Did anybody hold the pencil up and slide across? Did we touch anything more than one? Somebody said no, makes me wonder. Yeah, you should have recognized right here. That's in one line. What points are those? -1, 3. And -1, -1. And then it was a choose all problem, so you could have chose both of them. And you could tell me I used a pencil line test. Some of you said they were on the same line. Something let me know that I know those X's can't be on the same line. Somebody said the X is repeated. Make sure you let me know exactly what you're talking about. Questions about it? All right, so that was a quick review from yesterday. I'm gonna give you about 3 to 5 minutes to get our notes on today. Put your phone on your chair, in your backpack, whatever we go. You can use your same bell work paper, draw your little squiggly line. We don't believe in wasting paper. Notes for the day, we're gonna be looking at comparing functions. Give you a few minutes to get it there. Here we are, then you got a calculator. Gonna be number 1. Stay over there, black and white. Some more. Number 2. Madeline. 3. 4 there. 4. William. Let me see the back. Keep moving. So 9. 5. 5. 6. 8. Armani. 7. Kalia. 8. Alexia. 9. right here. Hey, Flower. Yes, ma'am. Isabella. Look here. Okay. If not, number 10. Banana. 11. Aaliyah. 12. Write that number down somewhere. That's gonna be your number. Okay, you fine. So just get 10. So every day you come in, you know you didn't have yours or didn't bring it with you. Just go ahead and get it before you come on, get to your seat and get comfortable. Yeah, that's fine. All right, so they moving into compare, mainly looking at two things: rates of change and initial value. Looking at two things: rates of change and initial value. up top, somewhere in the middle. All right, so I'm gonna go ahead and keep it moving. I don't know if we started late, right, or what. All right, so rates of change. Rates of change is pretty much the ratio of the changes of the X and Y values. Notice it told us it always stays the same. And then it told us another name for it is called slope. So at your level, if anytime you hear me say slope, that's what we're talking about, the rate of change. It also told us in that equation, it's M. Sound like something you want me to have that shouldn't even be in your pocket or whatever if it's dropping like that. So in both of those equations, M would be the slope or the rate of change. It means the same thing. All right, I gave us a formula it can be found with, and you will usually see it written like this: y2 minus y1 divided by x2 minus x1. They usually write it as a fraction. They rarely write it going across. And then it tells us we're going to need 2 points in order to find it. So if they give it to us in an equation, look for M or the place beside the X, that'll be the slope. And if they don't give it to us, we need to choose 2 points, put them in that equation, and then get it. And we'll show you how it works. Rate of change. The second part of that equation is the initial value. It told us that's the starting point. Or in other words, the y-intercept. It is the B in that equation. So in that equation, for y is in there plus B, B is the y-intercept. Tell you where we start, and then M will be the slope. That is always. So when questions asking us about slope and y-intercept, those are typically the two they're looking at. And then we already said it's the y-intercept, so that's pretty much where the graph crosses the y-axis. For your EDF, and what does it cross the y-axis? Those are things that help us get there. And then if they give us points, any point that has x as 0, 0, 3, or whatever, that's the y-intercept. So we're going to be comparing the rates of change and the slopes with the initial value. And then they told us they're going to give it to us in 2 different ways. So out of those 5 ways we discussed on yesterday, they'll give you a table and then they'll give you a graph and want you to compare. Questions about it? Everybody got what you need? All right, first one that we're going to look at. It says a biologist studied the growth of 2 different trees over a 5-year period. At the beginning of the study, she measured each tree's diameter. The biologist took the same measurement each year to determine the growth. It says the red maple in her study had a starting diameter of 4 inches. The diameter grew at an average rate of 0.3 inches per year. The graph on the right shows the growth rate of the silver maple tree. Which function has a greater rate of change? Talk to us. What's important? We're looking for the rate of change. How many things we talking about? 2. Remember, this is compared function, so we're going to have 2 things. So that's my first thing. I need to identify what 2 things. I need more than that. What 2 things? The diameter and the now, what 2 things? What kind of tree? The 2 trees. Yeah, so those are the 2 things we're talking about. A red maple and then a silver maple where they gave us a graph. So that's why I said they're going to give us information in 2 different ways. So for the red maple, what did they tell us? Don't say diameter, they said a starting diameter of 4 inches. Starting. Grew at an average rate of 0.3 inches. So this red maple. Starting diameter. Now we just took some notes. Did you have something that mentioned start? What? Initial value. So this is a key word telling me that 0.4, when that 4 is the initial value. It says grew at an average rate. What is that telling me? Well, you know, I said we are doing two things. So if that was initial value, then the average rate must be mine. Rate of change, what's the other name for it? Yeah. Can we write an equation for red maple? Go back to your notes. Now I know we wrote that equation for we said y equals mx plus b. M is the what? Okay, I wonder who took that note. And then it's plus b is the what? Y-intercept or initial value. They mean the same thing. So let me ask you again. Can we write an equation for this red maple? Yeah, we got both of them now. What's the slope? So y equals 0.3x. What's the y-intercept? It's positive, so positive 4. So for the red maple, we got y equals 0.3x plus 4. And we just wrote the equation with it. I know they mentioned rate of change. So that's just the slope, but it's already in that equation. Silver maple. What did they give us? A graph. How can we find the slope on a graph? Get 2 points. Get 2 points. On whatever graph they give us, we just gonna pick out 2 points. It don't matter what 2, any 2 that we pick, we should get the same answer. So looking at this graph, give us 2 points. 2, 4, I'll go with that. That's right there on the line. That's a little, yes, a little up. If anything, I'll probably do 0, 3. That would have been about 1, 3.5. So we'll use these 2. Get 2 points, and then I told you it's a formula to find slope. What was that formula? Equal. Okay. Divided by. All right, so definitely make sure we get that. They always gotta set it up as a fraction. So after we get 2 points, we're gonna be looking at y2 minus y1 divided by x2 minus x1. To help you easily identify your number. This is our first point, right? So this will be x1, so that's the first x coordinate, and that will be y1 because that's the first y coordinate. So then if that's the second point, that'll be x2, and then that'll be y2. A good rule of thumb, label your points, then when you start putting them in, we only gotta just put them up. All right, so what's y2? y1. So 3 minus 4 is the numerator. x2. x1. And then we're going to subtract and divide. 3 minus 4. 0 minus 2. Negative and negative. So positive 1/2. They never change it to a delta. Well, I won't say never. They rarely change it to a delta. So they'll leave that as 1/2. Since we don't went that far, we're gonna go ahead and write the equation for the silver maple too. So we just found our slope, 1/2 x. What's the y-intercept? Where did that those dots cross that y-axis. Good job. This is the y-axis, so that means I'm gonna then look right here and see where it crossed over and it crossed right there. And then I also told us anytime x is 0, that's your y-intercept. So the equation for the silver maple will be y equals to 1/2 x plus 3. All right, now they asked us to compare the rates of change. Red, what was the rate of change? Silver, what's the rate of change? Which is greater? 1/2. If you did not know, a half is 0.5 as a decimal. So then we would answer the question. What's that? Silver maple has a greater rate of change. And you go as far as to tell us why 0.5 is greater than 0.3. Always make sure we answer the question. Always. Question. Okay. Everybody got what we need. I'm gonna look at this one. It says Mrs. White buys a used car for $3,000. She makes monthly payments of $300 until the car is paid for. Mr. Brown also buys a used car. His monthly payment plan is shown in the table below. Find and compare the rate of change and initial value for each. Who we talking about? Ms. Brown, Ms. White, and Mr. Brown. Who we want to look at first? Ms. White? What did they tell us about Ms. White? Bought it for $3,000. Monthly payment for $300. And back to what we know. Slope is the rate of change or how much is changing at every instant. And we said initial value of y-intercept is a starting point. Or we're across the y, right? So based on the two digits they gave us, which would you say is the slope and which would you say is the y-intercept? Why? Good job. Monthly payment told me that's at a rate. So that must mean 3,000 is my what? That's my initial value. I mean, that's what I had to start with. Damn, I had to give you $3,000 before you ready to get the stock. And then each month I still gotta pay 300 additional. So what's our equation? 9 equals 5. Yes. Y-intercept is always going to be plus or minus based on its denominator, positive or negative. So in white, we got 300x plus 3,000. And we'll compare it later. Right now, we just need the information. Mr. Brown, they gave us a table. Looking at this table, what do I know? How you know? Good job. X was 0, so that's the initial value. She said he paid $2,400 to get started. What do you notice? He said it's decreasing, so we know that's a deduction. 300 each time? Okay, so what's our equation for Mr. Brown? Negative 300. back and visit his wife, because y'all should have thought so with Mr. Brown. His rate is what? It's decreasing. Shouldn't his wife be decreasing? So both of the rates are decreasing, we're taking it out, but I had to start with that and then we slowly working it down. So now that we have both, now we can compare them. What can we say about the rates of change? The rates of change are equal. That's because they recognize this negative 300x, and then over here we also got negative 300x. So the rates of change are equal or the same. What can we say about the initial values? This white initial value is greater than Mr. Brown. What tell us this? Then we just simply say 3,000 is greater than 2,400. Just remember, comparison, go back to how you used to compare in lower grade. Alligator eats the biggest number, is the less than, greater than, equal to. You got all this, Grayson? Oh, okay then. Questions about it? Again, with rates of change and initial value. Everybody good? All right, I'm gonna give you about a minute to have a look. Read it and have a look. All right, somebody talk to us. You said he do what now? Okay, because that's down payment or this okay, so that is what? Rate of change of slope is 10, okay. My bad. All right, so we done identified the slopes and the y-intercepts. And notice how I did it. You may want to get in there and do the same on your paper just so you don't get confused. Like, what's the slope over here? Just kind of write it there or draw it so you can see it. So now they say compare. What can we say about the rates of change? Rates of change? right, the rates of change are the same, or we can say equal. You might even put the number 10. Somebody kept saying pay $10 down. All right, what can we say about the initial values? Okay, I like that. That would say $5 more than Alfredo. And then you could possibly tell us 25 is greater than 20. Don't assume I know what a slope and a y-intercept is. Draw a line and label it. Say, hey, be catching. I know this is slope. I know this is y. But don't just leave it hanging and expect me to know what you referencing. It takes maybe 10 seconds to, okay, this is slope, that's y, to do this. Any questions on it? Good job. You all did fairly well with that one. All right, I'm gonna give you about another minute. If you're mad about us checking the phone throughout the day, but y'all stay blowing us up in this little school and everything. I just don't understand it. I just want to talk to you. Okay, she paid 151st. He said it decreased 25. Okay, he said that will be the rate of change. Okay. All right, so that'll be her initial value. Rate of change. And William reminded us that that will be negative. All right, they said Ron wants to buy a new wireless phone for $200. 2 stores offer different payment options. Which plan has a greater initial value? Which plan will be paid at a faster rate? All right, the first question. Which plan has a greater initial value? That's store B. All right, so no, don't just say A and go about your business. Let us know what you're talking about with A. A what? All right, the second part of that said, which phone will be paid off at a faster rate? Or A? For A. You pay a $5. I'm with you. We're missing one main little piece. What tell you 10 weeks? So we have to subtract. What tell you 10 weeks? Because the total is 200. Divided by 20, so we subtract 50. What you say? 200 divided by 20, so we subtract 50. So was the 50 his initial value? No. What was his initial? 200. Then he took out 50 and then we did 2020. So it may be best for us to do that at a short point. So we're going to start with the 200 and then we slowly work our way down. However, over here, did it cost $200? Over here, I got a discount. How much is the phone? 150. So for you have to pay the every like to think. All right, get your stuff situated. Coach R telling me I'm running over. You will have 3 questions again tonight, kind of similar to y'all know how we do about every day.